Polar equations. Find a polar equation that represents r as a function of theta for the rectangular equations 3x minus 5y is equal to 9. So I have an equation with x and y, and I want to change it to r and theta, where r is a function of theta, and I'm going to use these two formulas for the conversion. The x's, I'm going to convert them into r times the cosine of theta, and y is going to equal r times the sine of theta. X is r cosine theta, and y is r sine theta. And then I'm going to solve this for r, so I can have r as a function of theta. To solve it for r, first I'm going to factor out r as a greatest common factor of these two terms, and when I do that I get r times 3 times the cosine of theta minus 5 times the sine of theta, that quantity there, and that's equal to 9. And then to get r by itself, I'm just going to divide both sides by this factor, the quantity 3 times the cosine of theta minus 5 times the sine of theta. They'll cancel out on the left side, and I'll only be left with r, but on the right side I'll have 9 over that factor. R as a function of theta, r is equal to 9 divided by 3 times the cosine of theta minus 5 times the sine of theta. Let's go ahead and make this more general. And let's just go ahead and put this in polar form. So to put it in polar form, I'm using this for x and this for y. So this is a times r cosine theta plus b times r sine theta equals c. You factor the r out, and you get r is equal to a times the cosine of theta plus b times the sine of theta, which is equal to c. And then once again you can divide out that factor, a times the cosine of theta plus b times the sine of theta. They'll cancel out, and this will be just a standard form of a linear equation in its polar format. So this is the rectangular equation for a line, and this is the polar equation of a line. So if you're given an equation of a line like this one, this is A, this is B, and this is C in standard form. If you want the polar form of this rectangular equation, you just plug in negative 11 for C, 2 for A, and 7 for B, and you'll get this equation. So this would be the polar equation for that line in rectangular form. Here's another line in rectangular form, y equals 13. That's a horizontal line. So that's A is 0, B is 1, and C is 13. So you plug those in, you get 13 as C, A is 0, B is 1, and this is going to simplify to just 13 over the sine of theta. This is the general form of the equation of a horizontal line. It'll just be that constant divided by the sine of theta. And here's another equation, x equals negative 8. This is the equation of a vertical line. So A is 1, B is 0, and C is negative 8. So we get this. And when we simplify this, we just get negative 8 over the cosine of theta. And that would be the equation of a vertical line. So these are the three types of lines, and that's what their equations look like in polar form. All right, let's look at another equation. This is the equation of a circle. Let's look at what a circle equation looks like. This circle is centered at the origin. So the center of this circle is 0, 0, and the radius is 5. So let's replace. Let's do these replacements. X is r cosine theta, y is r sine theta. And then I'm just going to square r and square the cosine. I'm going to square r and square the sine, and I'll get this. Now I'm going to factor that r squared out, just like I was doing before. So I factor out the r squared, leaving just the cosine squared of theta plus the sine squared of theta. But that, by the Pythagorean identity, is just equal to 1. Cosine squared theta plus sine squared theta, that's just 1. And then r squared times 1 is just r squared. So the equation is r squared equals 25, and I just want to know the equation r as a function of theta. So to get r by itself, I take the square root of both sides. R is either positive or negative 5. I'm just going to take the positive radius here. This is the equation of the circle, just r equals 5. This is the rectangular equation, x squared plus y squared equals 25, of the circle centered at the origin with a radius of 5. And this is the polar equation for that same circle. Alright, what if the circle isn't centered at the origin? Let's take a look at this circle. This circle is not centered at the origin. It's centered at -2, 0, but it also has a radius of 2. So that means it's tangent to the y-axis. It just touches the y-axis. So let's see. Let's go ahead and convert it into its polar form. Here are the conversion equations. We replace x with r cosine theta and y with r sine theta. I can square this, but I have to FOIL it. When I FOIL it, I'm going to get r squared times the cosine squared of theta when I do first times first. Outside is going to be 2r cosine theta. Inside is going to be 2r cosine theta. So I get 4r cosine theta. And last times last is going to be 2 times 2, which is 4. So I FOIL this. Then this one, I'm just going to square the r to get r squared, square the sine to get sine squared, and it's still equal to 4. Then I am just going to combine things now, rearrange stuff. For instance, I can put this r squared sine theta and this r squared cosine theta together. When I put those two together, I can factor out that r squared, and when I factor out the r squared, I'm left inside with cosine squared theta plus sine squared theta. Once again, this is the Pythagorean identity. So that's equal to 1. And I just get r squared plus 1 plus 4 times r cosine theta is equal to 0. R squared times 1 is just r squared. Solving for r, I can factor r out of both of these terms. When I factor the r out, this becomes just r, and this becomes 4 cosine theta. And now I get two equations. I can set both of them equal to 0. One of the equations will be r equals 0, which is just the equation of the pole. The other equation is r equals -4 cosine theta. This equation includes the pole, so we can just rock with this one right here. And this would be the equation of this circle, and that would be what the equation of a circle that's not centered at the origin but tangent to either the x or y axis would look. Alright, let's take a look at the next question. Find a rectangular equation for the polar equation r equals 4. So this is going back in the other direction now. We're given the polar form of the equation and we want the rectangular form of the equation. So we need x's and y's. So here are the two formulas we're going to use for these conversions. To find x and y, we're going to take note of the fact that r squared is equal to x squared plus y squared, or the fact that the tangent of the angle theta is equal to y over x. Since this equation involves r, I need to focus on getting r squared. To get r squared here, I would need to square the r that I already have by multiplying by r in some way. So I can either multiply both sides of the equation by r, or I can square both sides of the equation. Multiplying both sides of the equation by r isn't a good idea here because I'd have 4r on the right side, and I don't have a direct translation for r. I'd be using some kind of square root. So it seems like the most logical thing to do here is square both sides of this equation. So I square both sides and I get r squared is equal to 16. Now I know what r squared is, and I see here that I can replace r squared with x squared plus y squared. So I'm going to go ahead and do that. I'm going to replace r squared with x squared plus y squared, and there is the rectangular equation. X squared plus y squared is equal to 16. Alright, here's another polar equation. I'm going to convert this to its rectangular form. I notice this one doesn't have any r's, but it does have theta equaling pi over 3. And I know that the tangent of theta is equal to y over x. So that means that if I take the tangent of both sides of this equation, I'll get this. I know that the tangent of theta is y over x, and I know that the tangent of pi over 3 is the square root of 3. And I can solve this for y by multiplying both sides by x. Here is the equation in rectangular form. Let's take a look at the next question. So we have here, find a rectangular equation for the polar equation r equals -4 times the sine of theta. So once again, we need the r squared and we only have r. So to get the r squared here, I could square both sides like I did before, but I don't know what I would do with the -4 times the sine of theta squared. I'm not sure what I would do with that. What I do know is that if I have r times the sine of theta, I can replace that with y. So if I multiply both sides of this equation by r, that's a better option, because multiplying the left side by r is going to give me the r squared that I need, but multiplying the right side by r is going to give me an r times the sine of theta, which I know I have a replacement for. So on the left side, r squared, well, r squared is x squared plus y squared, but on the right side, that's just going to be -4y. And this is the rectangular form of that polar equation. All right, let's take a look at the next question. Here I have find a rectangular equation for the polar equation r is equal to 6 times the secant of theta. Well, I don't have a relationship for the secant of theta over here, but I do know that the secant can be written as 1 over the cosine of theta. So I'm going to rewrite it that way because I do have that x is equal to r times the cosine of theta. Let's simplify this a little bit first though. So we'll multiply 6 times 1 to get 6 over the cosine of theta. All right, from here, I want to get rid of the fraction. So to get rid of this fraction, I'm going to multiply both sides of the equation by the cosine of theta. When we multiply both sides by the cosine of theta, on the right side, they cancel out. On the left side, I get r cosine theta, which I actually know what that equals in rectangular form. When these cancel, I just get r cosine theta equals 6, and r times the cosine of theta is just x. So the final result here, the rectangular form of that equation, is just the equation of the vertical line, x equals 6. All right, let's take a look at the next example here. Here we have find the rectangular equation for the polar equation r squared times the sine of 2 theta is equal to 4. Well, for this one, we're going to have to use an identity because this isn't just theta, this is 2 theta. So we're going to use the double angle identity for the sine. The sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And once I have that, I can then take this r squared and split it up amongst the sine of theta and the cosine of theta to get this 2 times r sine theta, which I have a replacement for, times r cosine theta, which I also have a replacement for, is equal to 4. So this becomes 2 times y times x equals 4. Solving this for y, I can divide both sides by x to get y is equal to 4 over 2x. Then I can cancel out the 4 and the 2 to get just y is equal to 2 over x. And this would be the rectangular form of that polar equation.